important. Okay, so for example, for number one, I don't know what's number it is this. Given the curve fx equals x square, square root x plus 3x, find the equation of the tangent line where x equals 1. So first thing first, you need to find the coordinates. Okay, so the coordinates of fx where x equals 1. So you need to put f1. So f1 is square root 1 plus 3 times 1, right? So it is 4. So the coordinates, okay, 1 plus 3 equals 4, that's simple, is 1, comma 4. This is for x, comma y, right? And then what next we can do is try to find the gradient. So this is the first step, find the coordinates. The second step, find the gradient. What is the gradient? We use the dy dx thing, right? But before we do the gradient, we have to make the fx simple, or y equals, right? Fx equals y, x power 1 over 2 plus 3x, as given in the question. Okay, this is right. So your working is right, but you need to give all the info, because if you don't give the info, you will get confused or you will get lost somewhere. Yeah. So do the step-by-step thing. So dy dx. So I want to find the gradient. Is half, we'll put below, remember, x power half minus 1, or you can just do negative half. You can do it fast. That's good. That's a good thing. Plus 3 times 1, right? So 1, x power 1 minus 1, x power 0 is 1, so 3 itself. So let it be. So that's the answer. Okay. So what next? We need to find the gradient where x equals 1. So we have the point already. Now we need to find the gradient. So the f accent 1, right? Because accent means the derivatives. Or I think if you don't get used to fx, what you need to do is try to find m where x equals 1, right? So half times 1 power negative half plus 3, right? So all the x supposed to be changed into 1. And then 1 power anything, it can be negative half, 1 itself. So half plus 3. So it is 3.5. It's the same? Wait, it's wrong. Not 3 over 2. See, you did something wrong here. 3 plus half is 3.5, or 7 over 2. Okay, so this is wrong, yeah? So you know what's wrong now. After you get this, you get the m and y, the point. So we have x comma y, 1 comma 4, and the gradient 7 over 2. I just make it into an improper fraction, yeah, and that's better for me to understand and for you to understand as well, rather than the mixed fraction. So to find the line equation, what you need to do is try to use y equals mx plus c, right? As you did just now here. So y is 4, right? Just put it here. Y equals 4 equals m times x plus c, right? The x is 1. So 4 is 8 over 2. I think we just make into total fraction plus c. We get the c now, 1 over 2, right? We have the m, we have the c. So what next? This is already a gradient and intercept form. Remember? This is line equation for the last year, maybe last semester. Gradient, intercept. So the formula is y equals m, let m be 7 over 2, x plus 1 over 2. This is your final answer. If you want to modify further, yes, you can. Surely you can. You multiply by 2. So 2y equals 7x plus 1. Or 7x minus 2y equals negative 1. Up to you. You can either this, everything is right. Get the idea, Vicky?
Yeah. So the final answer for that was like 30 over 7 or something. I think the question also mentioned find the normal equation, meaning like
Okay, good. Yeah, normal line. Okay, I will copy this first, and I think I need to put in Word, Microsoft Word. Give me a moment. Find the equation of the normal. I also teach this in my class. That's the same topic. Wait, give me a moment. Wait. I think I need to delete this. So the first step, but do you get this idea? the idea about this? Find the equation of tangent.
Yes.
Okay, nice. Now we are finding the equation of the normal. Okay, I think we need to delete this of the normal. I just changed this. I just want to make sure that you understand. Here of the normal, I changed the question. So do you know what is normal line? What do you know about normal lines, Vicky? Just let me know about normal. What is normal line?
It's like perpendicular to
There you go. Nice.
straight line.
Normal is always perpendicular. I just use this one, yeah, 90 degree to tangent. Do you remember what is the perpendicular rules for the gradient? So this is the gradient of the tangent, of course, right? So if you derive something, you are finding the gradient of the tangent. So this is always mt. I just use mt here. So mt, m of tangent line is 7/2. So if you want to find the normal, you need to do the negative reciprocal. Remember that rule? I always say that to all my students. 90 degree is always negative reciprocal. Negative reciprocal. Yeah. So when mt equals 7/2, the m normal, mn, I just write mn, equals negative of this, negative of 7/2, and switch it. Understand? That's the way I think. Some of the teacher
Yeah.
might be mt times mn equals -1. I don't think this is necessary. It just wastes your time. Just switch and negative. For example, if I have this is out of the question. If I have mn equals -5, what is mt? Negative reciprocal, right? Negative becomes negative of negative, right? Negative of -1/5, right? Or negative of 1/-5, or 5 itself, 1/5. Get the idea, Vicky?
Yes.
What you need to do, so from negative to positive or positive to negative, and the number is supposed to be switched the denominator and it's by its numerator. Okay, for example, I will give you some more hard question, hard gradient. So mt equals -3, 1/2. Wow. Or -3, 3/5. Oh, it's so hard. No, I will give you another 4/5. What is the mn? So before you do the mn, you have to change into improper fraction. 15 plus 4, 19/5. If you do this, it's way more simple. Negative becomes positive, 19/5 becomes 5/19. Okay, so another example, mt equals 8. Seems simple, but quite tricky. So if you don't have the power, if you don't have the denominator, you just put 1, right? So 8/1, negative reciprocal from positive becomes negative. 8/1 becomes 1/8. That's it. Okay, that's the way you need to think of the normal. And the point is also the same, Vicky. The point is also 1,4, right? Because when I have a curve, any curve, let's say this curve or this curve, up to me. This is the tangent. For example, I just use the red color for the tangent. The tangent is the line that passes through the point only at one point, at that point itself. This is the tangent line. What is the normal line? The normal line is always 90 degrees from the tangent line with a certain point. Wait, this is the point. Okay. So it can be elongated for depend on how much you need m normal. See, they share the same point. So mn is 2/7. The point is 1,4. So again, y equals mx plus c. We use the normal now. We are finding the normal line. And then y equals 4 equals -2/7 x plus c, right? And then we can find the c. So 8, oh wait, over 7. It's challenging. The number is so bad. -2/7 plus c, right? So 28/7. So the c will be -2, put to the left side. plus. So 30 out of 7. See, the 30 out of 7 comes out, and it's quite simple now. After you get this gradient and the intercept, just write y equals mx plus c. So y equals m negative 2 over 7x plus 30 over 7. Or if you want to make it more simple, you multiply by 7. So 7y equals negative 2x plus 30. How's it, Vicky? Do you understand so far?
Yes.
Okay, nice. I hope you know, now you know how to do. Again, the formula of the normal here. Normal to the tangent is negative reciprocal, or tangent to the normal, up to you, depend on what you want to start from. Okay, I will give you some question. I think I have it. Wait, give me a moment, yeah. Wait, mana ya? Wait, I'm finding. Give me a moment. Sec 4. What grade are you thinking? 10 or 4? It's the same, by the way. 10, yeah.
10.
Okay, so it is IGCSE. I use IGCSE, but it's called Sec 4, secondary 4. Wait a moment, I will give you some question. Let me know whenever you have any problem on working on this on this question. Wait. Math Sec 4. I'm opening the folder. It's too detailed. As 4 at math differentiation. Chapter 11. Yeah, that's it. That's it. This is the question. Wait. There you go. So this is what I teach in school. At school, it's the same as gradient functions. The red line is a tangent line, and the normal is always 90 degree. I haven't teach that, but they know right now. And this is a derivative. The formula, I just give the formula. I don't give the limit. It's too much if I teach the limit, wasting time, because at the end we have to understand the idea, the shortcut. Okay, 5 rules: addition, chain rule, right, and so on, product rule. I think you have learned this already. Equation of tangent and normal. See, normal tangent is always sharing the same point with normal, but tangent is at one point and normal is cut through the curve and at the same point as well. But we know that this is 90 degree. The tangent to normal is m1 times m2 equals -1, or I can say this is negative reciprocal. I will give you the file for, later. Bonus for you. Reciprocals. And parallel means they share the same slant, same gradient. Okay, so m1 equals m2, and we can use the equation y equals mx plus c. You better use either one. Don't use this. Use the second one. I mean, use mx plus c, and you can find m, you can find c. After you get the gradient and the intercept, just put it back. There you go. Find the equation of tangent at the point where x equals 2. I will copy this to the sketchbook. I have some question for you. Have you ever learned about the product rule and quotient rule, Vicky? The one that use u x and v. If I have y,
Yeah. This is what.
have you learned this?
I don't know what that is.
Oh, the product rule. This one. Wait, I'm opening the book. A moment, your book. 0606, right? I just want to make sure.
Yes.
Okay. This one. Have you ever learned about EFG? That's E, of course you know how to do FGH.
Oh, we're about to go into that, I think.
I see. Okay, so you don't have to do this. No, this you still can do this, but you cannot do this, of course, because this is the division. So you haven't learned this yet. Later. I think that's all. Only one number. Okay. Okay, no need to explore this. I want to delete. I better use the Word, Microsoft Word. A moment. So this is our lesson just now, the idea, and then some questions. I just use a page break. This is for your exercises, and that's for number 1. Now number 2. Okay, you can do it right now, yeah.
Okay.
And we will discuss about that later. I think I just make it simple, but I want to make sure that you understand the logic. Three number only. Yeah. Okay, that's all. There you go. Wait, how I can put it? Oh, I see. Yeah, there you go. Okay, so good luck, Vicky. Let me know whenever you have any question. Yeah. What you call tangent and normal line differentiation. Okay, I'm giving you time until 5:40 might be, maybe, and then after you do 5:40. Oh, okay. Almost. I think it's lost. Okay, 5:40, and then we're gonna discuss about this later. Yeah. Hmm. Okay, again, Vicky, let me know whenever you have any question. Yeah, don't hesitate to ask.
Okay.
Give me a moment. I'm going to Okay, so tangent and normal are two different things, right? Remember, you did this already. Gradient of tangent is equals to -1 over gradient of normal, right? The negative reciprocal. And since gradient of normal also negative reciprocal of gradient of tangent. Stationary point. What is stationary point? Where the dy dx or the gradient of the tangent is equals to 0. Okay, we will do until this part first because I don't want to go too far. Kinematics, rates of change, optimization, and so on later. So the gradient of tangent equals to 0. That's the idea. Why? Because I want to give you some example. Let's say this is the curve. I um I like this kind of curve because we can do all the general part. So what is stationary point? Stationary point is the turning point. The turning point is located here. We have 4 turning points. And for 4 of them, they share the same features. What is the same features? Their gradient is, their tangent line is always straight line, right? So if it is straight line, the gradient of tangent equals 0. Gradient equals 0 because it's horizontal line. Make sense of this? Understand?
Yep.
Okay, so let's go to question B. So this is the idea. Yeah. Let's do stationary point. A tangent curve, it's the same. Normal, see, it's the same also. That's the way you have to do. See, consider a function this. You have to find the fx and x or the differential and find the values of x at which the tangent to the curve is horizontal. The tangent is 0. See, horizontal line, straight line like this, straight line, horizontal, m is 0. So 0 equals the derivatives. And this is the preface or the introduction to the next part. There you go. So much. Stationary points. See, stationary points give the same features. Local maximum, fx and x equals 0, or the gradient is equals to 0. So I don't think it's too hard. And stationary point of inflection, points of inflection means the gradient also fx and x is also 0 when x equals 0. Okay, and point of inflection here, why it is called inflection? Because when it is positive, the gradient is also again positive. Yeah, wait, I think I need to give you this. Wait. Exercise. I don't think we need this. So we have to go back to the first part, the A, because this has to be mastered. Okay. You need to master this number 17. Okay. I'm giving you time sometimes to do number 17. One more question, I think. One or two questions. We still have about 16 more minutes. We have so much time left. Okay. Wait, 16 and 17. There you go. 16 is quite complicated.
Okay.
So, and we will I will explain it to you later on. So I don't think I need to explain this part because this is simple. You did all the good job. Okay, there you go. Okay, so we have the curve like this of x cubed and the thing at the point 2, x equals 2. What is the tangent? And where the tangent, so we have to find the other coordinates where the line meets the curve, right? So I already get the line equation. This will be the line equation. And when the line meets the curve, they share the same point. It means y equals x cubed for the curve and y equals 12x minus 16. They share the same point, means same y or same x. But in this term, we prefer use y curve equals y line. Okay, y curve is x cubed, y line is 12x minus 16. And x cubed minus 12x minus 6 plus 16 equals to 0. And with the idea of factorization, you will get x equals either, wait, I use my calculator so you can see this clearly. Wait, We need the calculator in order to solve this. Yeah. I think we can just do one or two more questions. One more question after this. Wait. So I use mode and using cube 4, yeah. Ax cube plus bx squared plus cx plus d. So ax cube plus bx squared plus cx plus d equals to 0. Okay, and then the a will be 1, right? A will be 1. I'll put 4. A will be 1. B is 0, right? Because you don't have the term of x squared, put 0. And C is -12 cx, and the D will be 16, and the answer will be -4. 2, and one more. Do we have one more? Okay, just two numbers, -4 and 2. So we have -4 and 2. As you can see, the x as 2 is already occupied for the question, right? So you need to ignore this. So we get x equals -4, and we can find the y, right? The y equals -x squared, x cubed, -4 cubed. Okay, -64. So that's the answer. So -4 and -64 comes from this equation. They share the same point. And if you can see this, it's also the same, -4,6, -64, and they will not meet each other at another point except 2,8 and -4, -64. Understand, Vicky?
Yes.
That's hard. This is hard. It's quite hard, but I think that your teacher will go to this part as well, because your teacher haven't done his or her explanation about number 16.
Basically, just need to do the y line equals, I mean, y curve equals y line.
I see. Okay. What else? What else? Do you have any question?
No, I don't think so. Because the homework he gave us, he only gave us till 11 AC.
Oh, okay. Have you done all the homeworks?
Nope, he just gave it today, but it's due Thursday.
Oh, I see.
So